Thank you, Dima, for the introduction. This is actually the first Ukrainian conference that I'm speaking at, so I'm really excited to be here with you guys. And I also decided to come here and speak to you and tell you one important thing, which is I have an addiction. Yeah, it's true. I'm really addicted to reading a source code, as you can guess, and it's actually Angular sources. So I want to share with you today some insights that I discovered while reverse engineering Angular. And yeah, also known by NgWizard in the community. This is actually the name that one of my regular readers came up with. So if you want to find me on Twitter, that's the NgWizard name you should use to look me for. Okay, so just a little bit about myself, but I guess there's been a lot already said about me, but I'm a Google developer expert in web technologies in Angular in Ukraine, next to Dima. I'm also a developer advocate and a growth hacker at AG-Grid. And also founder of Angular in Depth. So this is the place where you can find explanations for the most challenging Angular topics. So check it out. Okay, now I want to talk to you today about Angular modules. And why Angular modules? Well, because I personally find them really confusing. And yeah, maybe not that confusing, but when I first started to work with them, yeah, I find a few things puzzling. For example, we all know that we have encapsulation in Angular for static components, right? We need to specify them in exports, so you then can use them in other components templates. So when working with modules, I was kind of expecting something similar for dynamic components and providers. However, in Angular, there is no encapsulation for dynamic components and providers. So I was kind of surprised. Then, in Angular, we break up applications into standalone modules, right? And then we compose an application by importing these modules. So I was under the impression that, okay, if I import one module into the other, then there must be some kind of hierarchy created. However, as I was reverse engineering Angular modules, I learned that there is no hierarchy, which was very surprising. And today you will also learn why. And the last thing, so we have lazy loaded modules and eager loaded modules. And most documentation on the web can make you think that these are actually two different kinds of modules. But in reality, there is absolutely no difference between eager and lazy loaded modules. And again, I will prove it to you today. So I don't think that modules or anything else should be confusing. And to me, the best way to avoid confusion or clear confusion is to learn how things work under the hood. So I'm taking you on a journey today into the internals of Angular modules. So we will learn about the relationship between modules and injectors. Specifically, I want to show you today how modules are converted into injectors, how providers that you define on the module become available in injectors through the dependency injection mechanism. And to do that, I will tell you a little bit about my experience reverse engineering Angular modules. And I did that while I was working on a plugin-based application. I was working specifically on an extension mechanism. And my task was to load these plugins into the application and then use them as part of the application. So today you will also learn some insights into how to build a platform with Angular. Okay, let's get started then. So here, this diagram represents the application I was working on. So basically, it's very similar to the diagram designer. So we have a toolbox with widgets, right? We just pick a widget we drag and drop it on the canvas. And when we have a few of these widgets, we can make connections between them and draw a diagram. So where this application is interesting is that the default set of widgets can be extended with widgets implemented by third-party developers. So if you think about it, it's similar how we extend our applications with jQuery plugins, right? Someone writes them, you just load them, plug it in, and have the functionality out of the box. So this is exactly the case, maybe a little bit more complex. So here's the relationship between a platform that I was working on and the extension modules built by other developers. They implement widgets as components, then they package them in Angular modules, and then we load them into the application in runtime. So I was working on this extension mechanism. Specifically, the logic that will load this extension module will retrieve widgets provided by that module and use it as part of the application, render it in toolbox, and allow rendering on a canvas. Okay? Now, you might be looking at that now and thinking, okay, so why is that difficult? Why bother? No? Well, so here's the question, and let me show you exactly why it was challenging. And to do that, I will use Angular Material Library as an example. So this is how we extend our applications with this library, right? We simply import an extension module with widgets or components, and then we use them in our templates. I think most of you have done it a million times, right? But I think you haven't noticed a few important things about this particular setup. First is that we know exactly which components or widgets are provided by an extension module, right? In this case, it's the button widget, the button component. And second, you see here that we import this module explicitly, right, during build time, during configuration time. So we know in advance about all the set of modules that will be used as part of our application. We have all the information we need in advance. So you may be thinking now, okay, can it be otherwise? How can it be that I do not know all that information? Well, actually, that's exactly the case with the application I was working on. So let me show you how it can be. The reason for that is third-party developers can put as many widgets as they like in an extension module. And then they don't provide information in advance about what widgets are part of a module. And second thing is each widget can also have a server-side implementation. So it has to be deployed to a server, right? So it consists of two parts, the client part and the server part. And it means that until after the application has bootstrapped and I made a request to a server to request this set of all the widgets that are deployed, I do not know which modules and widgets I need to load. Which basically means that every single extension module implemented by third-party developer would have to be loaded lazily. Right, so these are the challenges. We need to load everything lazily in runtime. And we need to figure out which widgets are provided by a module and yet somehow retrieve them. Now, this is really, really challenging. And what do you do when you face a difficult challenge? I don't know about you guys, but I personally usually take a vacation. You know, sunshine, beautiful beach, sea, relax, why bother? However, I took a vacation, but I didn't spend it like this. More like this. I was actually debugging the router implementation. And why router, right? Well, if you think about it, Angular's router solves similar tasks. It needs to lazy load modules sometimes, right? It's for performance reasons. And second, when we implement a lazy loaded module with routes, the router needs to somehow figure out which routes are part of that module, right? We don't explicitly say that. So I could actually map this easily to my own problems, and then check out how the router does it, just needed to figure out that, and just use the same approach. So let me show you what I found. Now, this gist demonstrates what the router does to lazy load a module and retrieve the routes from this module. I have removed all the relevant stuff and ended up with just 4 lines of code. And this is the essence of what the lazy loading means. If you understand these 4 lines and the concept behind these 4 lines, you will have known the internals of Angular modules. And while looking at that, I don't expect you to know right away what it all means. Honestly, when I took a look at that first, it wasn't clear for me as well. So I needed to spend at least a month going through different stuff and trying to understand different concepts to figure out what is going on here. So what I want to do, I want to go over these concepts now. But first, let's just go over these 4 lines and quickly, I'll tell you quickly what it's doing. So first, it's loading a module class. What is module class? It's simply a JavaScript class with ng module decorator applied to it. So then, once it loads it, then it compiles it. As a result, we get a module factory. So then this factory is used to create an instance of a module and an injector, and we use the injector to retrieve the widgets. Okay, again, there are a few things we need to understand before we can understand all the stuff that's going on here. And I think the most critical one you need to understand is a module factory. We all know that, or at least we now know after the Shmuela's talk, that dynamic components, or actually all components in Angular, have their factories, like component factories. But actually not many people know that in Angular we also have module factories. And there is a specific compiler that works with modules. Okay? So, what is this module factory? Well, and how do I get across it? Well, I personally first encountered it when I was debugging sources, and I found this ng folder generated by Angular compiler. It's generated by the JIT compiler. So if you open Chrome Developer Tools and check for the folder, you will see it there. And as you can see on the screen, it has a module factory inside and also the component factories inside. Okay, so I got interested. Okay, we have this module factory. Then I went into the sources and I found this thing, ng module compiler. That takes a module class, right, as I said, it's JavaScript class, simply JavaScript class, and generates something called module factory. So this module factory, it's basically just a set of provider definitions for the providers that you define on the module. And these definitions, the important thing is, these definitions, provider definitions, specify some relevant metadata. Like, for example, dependency, right? Which provider needs to be instantiated first, the order of instantiations. For example, if you have 2 providers here, A and B, right? And B provider specifies a dependency. It depends on the instance of A. So Angular needs to specify that whenever you request the B provider, it first has to create the A provider. Right? It's sort of a metadata, a description that defines the order of instantiation. And if you check the module factory or definition, you will see it there, right? There's this depth property that just dependencies that specifies, okay, if someone requests a provider using the B token, we need to first instantiate the provider that is referenced through the A token. Okay? So we have this module factory. Okay. Now, where is it in this particular gist? Well, it's the second line, right? Once we've loaded JavaScript class to client, then we use the compiler and pass in this class, and as an output, we get a module factory. Cool. So we have a factory. What do we do with that? Well, actually, it's easy. Once we have a factory of a module, we can create an instance of a module. Similar to the components, right? Once we have a factory for a component, we can create an instance of a component. So here, I'm calling the create method, or the Angular router calls the create method, passing parent injector to create a hierarchy of injectors. And it's interesting that in Angular, internally, there is no difference between a module instance and an injector. Well, basically, a module instance is an injector. So this injector, you can guess, will have all the providers that you've provided in this module that was compiled. In here, the router simply uses some token, routes token here, to retrieve these routes from the injector. All right. Now, here's the overview of the entire process again. Just for you to remember that. You see, it's the third slide that I'm talking about module factory. It's like, it's a critical part. And so, again, if you haven't listened to what I said before, just look at this slide here and try to focus on that and try to understand it. So on the left, we have a module class, which is JavaScript class with ng-module decorator applied to it. Then we compile it. We can use JIT compiler or ahead of time compiler, but anything, just compiler. We have a module factory, right? We saw this module factory. Simply provider definitions and metadata, which depends on what. And in runtime, we call the create method on the factory, and we get an instance of an injector, right? With providers provided by that module. Okay, so you're looking at that now, and maybe you're wondering, well, we have so many modules in Angular. Does every single module in Angular have its own factory? Well, we can test it. Here I have two modules, A and B, right? They are both imported into the main app module. So, can you guess how many factories are going to be there when Angular compiles this app module? I saw 3 there. Well, actually it's 1. So for those of you who guessed 1, you got it right. It's interesting that Angular compiler only creates factories, module factories, for the modules that are being compiled. And in our case, it's the app module that is being compiled. However, it's interesting, right? We had here A and B modules, and both of them had their own providers. So where are these providers? Well, this app module factory includes all providers from all imported modules. And since we have only one factory, we had 3 modules, but only one factory, we will have only one single injector, because we use one factory for that. And it's actually the injector that Angular calls the root injector, right? That has all the application relevant providers inside. Okay, one important implication here. It doesn't matter how many modules you import one into the other, and how many modules you have, there's going to be only one factory and one injector. Now, once we know that, let's get back to the common confusions that we started with and review them again with the background about the factory and all the compilation instantiation process. So I told you, there is no there's no encapsulation for dynamic components and providers. Well, it's because dynamic components and providers can be used dynamically, right? Whenever we need them, we can dynamically create a component at any point in time and put it in any place in a template. We can inject any provider that we want dynamically. And so the Angular compiler, when it compiles all these modules and tries to generate a module factory, it doesn't know where and how you will be using these providers and components, right? Essentially lacks information about the usage. And so at this point, it cannot enforce encapsulation. However, after the compilation, we no longer have multiple modules. We have only one single module and single injector. So at this point, there is no way to enforce encapsulation either. That's why there is no encapsulation for dynamic components and providers. No modules hierarchy. Same thing. Modules hierarchy can be created when we have multiple modules. But after the compilation, there's only one single module. There's nothing to create hierarchy from. And eager and lazy loaded modules are the same. What did I mean when I said that? I meant that both eager and lazy loaded modules go through the compiler. They both start as a JavaScript class with a decorator, and then they go through the compiler and end up as a component, as a module factory. And then again, they both go through the same instantiation process. The create method is called both on eager and lazy loaded module factories. The difference is that the lazy loaded module, this JavaScript class, is just loaded a bit later, right? Later at some point in time. All right. Now, I've shown you the background. Now let's get back to the process and the question I started with. So here's how I implemented loading third-party widgets. So we load the JavaScript class, we compile it, and we get a module factory. You already know that. Interestingly, I mentioned that briefly. This is the JIT compiler that's used here, if you compiled on the client side. However, you can easily optimize that using ahead of time compiler. Just take the module and compile it during build time, and you have a factory as an output. And then simply load this factory to the client. Now after that, we can create injector in runtime, simply call the create method on the factory. Pass in parent injector, and we have an instance of a module and an injector with providers that are relevant for this particular module. Again, lazy loading. This is the lazy loading. This is it. We load module, compile it, get module factory, and an inject. You see, it's simply the same way we do with eager loaded modules. So we have an injector. Right, so we have an injector. What do we do with that? We need to somehow get access to these widgets that are part of that module. Again, I needed to take a look at the router implementation. How does it load these routes? Well, this is the router module, and you all know that it has two methods, for root and for child. Well, it's interesting that they are quite plain inside, quite simple. They just register the routes that you provide as a provider, right? You pass in for root and for child, you pass in the routes. And inside, it simply registers them using the routes token. This is not much simplified code from the original, actually. So I could do the same, okay. Third-party developer can register the widgets provided by a module using some kind of token. And when I have an injector, I will use the same token and will retrieve these widgets. That's exactly what I did. Here's the relevant implementation. So I'm using here the widgets token, and I'm registering a widget definition with two important details. The first one is the name of the widget. This is for internal use. So we can have a registry of all widgets, and work with them internally. And also the component that implements these widgets, right? Because I told you, developers implement widgets as components. And that's it. So once this module is compiled and I get an injector, I will use the widgets token and will retrieve these widgets from the module and an injector. Finally, we've come to the real code. And now that you know all the stuff around that, I hope you will be able to easily understand it. So we load JavaScript class, we load this module with widgets provided by this module. Right? You can use any module loader, but at this point of time, System.js is actually the only loader that can load module dynamically. Right? We have Webpack as well, but Webpack cannot load something that it doesn't know about during build time. Okay, so I'm using System.js. I've loaded this JavaScript class, this module. So then I compile it, get a factory, and create an instance of an injector. Now you know what? We are going to get our widgets using the same token, exactly the same token that these developers used to register these widgets. And finally, if we need to render that inside the toolbox. Right? And Shmuela did a great job, previous talk, explaining you how to render dynamic components. And these are essentially dynamic components, right? We don't know about them when we put together our templates. So you can reference her talk to figure out how to do that. Okay, so what I want you guys to do now is take a second, look at all this code here, and appreciate how much you can learn through reverse engineering, through hardcore debugging. All this information was not available at the time I was trying to solve this task, and honestly, it's not available anywhere else except on Angular in-depth at this point. Because it covers a lot of internals of how Angular works under the hood. So maybe next time, when you're feeling stuck and assigned with a difficult problem, maybe you can find the courage to take a deep dive into Angular sources or any other project sources. And to help you with that, specifically with Angular, as already been mentioned, I created this Angular in-depth hub where we publish stuff about that explains how Angular works under the hood, best practices on complex stuff. So we specifically are focused on in-depth stuff. Right? And it's been mentioned a few times here that I write a lot of articles here, but it's not just me. We have a great community of people that help me write articles. We have people from Core.js team, from NGRX team that I think at this point contribute a lot more than myself to this publication. Okay, a few useful resources. So I've put together a sample application that you can use to follow this talk on your own. And I've written a few articles on dynamic components and common confusions with Angular modules. So if you want to, again, have a deep dive, check it out. Now, the last thing. Wise people say that truth lies within. And in case of Angular, it's where? It's inside Angular sources. So don't be afraid to read them and learn the truth. But always remember that nothing stays the same. So you can get in touch with me on Twitter. This is my handle. And good luck with your development. journey, and thank you.